PDF of a continuous random variable capital X is given by f of x is equal to x by 2 into e power minus x by 2, the range x greater than 0, 0 x less than or equal to 0. Obtain CDF of x. CDF means cumulative distribution function. Second one, probability of x greater than 1. Third one, probability of 1 less than x less than 2. Fourth one, E of x square. So from the given PDF means probability density function. From the given PDF, we want to find out this. Okay. So now in this problem, first question, I want to find out the CDF, cumulative distribution function. So the formula for CDF is capital F of x is equal to integral minus infinity to x f of x into dx. So this is the formula. Now in this formula, integral, the range starts from 0 because x greater than 0, so that you have to take 0 to x. F of x is x by 2 into e power minus x by 2 into dx. Okay, now I want to integrate this function. So now to integrate this, there are two terms which are in product form. One is algebraic term, another one is exponential term. So to integrate this type of function, we have to apply Bernoullis method. What is Bernoullis method? The Bernoullis method is, you have to use like this. For example, you take first, for example, if you can take x square into e power ax. Suppose this is, here I want to apply Bernoullis method because this is the product of two functions. One is algebraic, another one is exponential. So the Bernoullis method is, take algebraic term first, integrate the remaining term e power ax by a minus differentiate this algebraic term 2x and integrate the next term e power ax by a square plus differential of 2x is 2 and then integrate this e power ax by a cube. So this is Bernoullis method. So this method I am going to apply here. Okay. So what is that? This is algebraic term. This is exponential term. By the Bernoullis method, take algebraic term first, integrate the remaining term. Integration of e power minus x by 2 is e power minus x by 2 by coefficient of x minus 1 by 2. And then first term is positive, next negative. Differentiate this term 1 by 2. Integrate this e power minus x by 2 by again minus x minus 1 by 2, but minus 1 by 2 into minus 1 by 2, 1 by 4. So this is over because here constant. If you differentiate this, it will be 0. So this is Bernoullis method over. So what is Bernoullis method? Take algebraic term first, integrate the remaining term, minus differentiate this and integrate this. So next if you differentiate this, it is 0, so we can stop. So Bernoullis method over. Now I am going to substitute the limit 0 to x. Okay, so here this 1 by 2 cancel, so remaining minus can take here, so minus x into e power minus x by 2, and here minus denominator of denominator 4 can take into numerator, 2 and 4 cancel means 2 into e power minus x by 2. So limit 0 to x. So now I am going to substitute upper limit first. Substitute x wherever x, so same function will come, minus x e power minus x by 2, replacing x by x, same top function will come, 2 into e power minus x by 2. So this is upper limit minus the lower limit. Substitute 0 for x, so 0 into anything 0. Substitute 0 here, e power 0 1, so only 2. So after this, first minus of minus plus 2, so take 2. Next minus x into e power minus x by 2 minus 2 into e power minus x by 2. So this is capital F of x. So this is the cumulative distribution function, that is CDF. The range is x is greater than 0. So this is the first question over. Okay, next I am going to find out P of x greater than 1. Okay, so for this we have formula. The formulas are, you see, Our required formula is here. So first you see all the formula. First formula, probability of between A and B. P of A less than X less than B. There are two formulas for this. One is using PDF, another one is using CDF. But what is PDF? PDF is the probability density function. Probability density function means small f of x. CDF means capital F of x. So that means there are two formula. First one is using small f of x. Suppose second one is using capital F of x. That is using PDF. Another one is using CDF. So based on our requirement, we can take the formula. You see the between A to B is using PDF is integral A to B f of x dx. But the next one, same formula using CDF is f of B minus f of A. Similarly, for a P of x greater than A is using PDF is integral A to infinity f of x dx. Greater than A mean it goes to infinity. So therefore A to infinity f of x dx. It is using PDF. Suppose using CDF, P of x greater than A means A to infinity. Using CDF, P of f of infinity minus f of A. So this is using CDF. By similarly, third formula, P of x less than A means minus infinity to A f of x dx. This is using PDF. For using CDF, this P of x less than A can be written as minus infinity to A. That means capital F of x. Using the capital F of x formula, f of A minus f of minus infinity. So these are all formula using both PDF and CDF. Okay, now here the question is P of x greater than 1. So that we can use greater than A formula. Greater than 1 means we can use both CDF and PDF. If you use PDF, we have to use this function. If you use CDF, you have to use this function. Okay, so better you can use CDF method, because if you use PDF method, again you have to integrate like this. You have to apply Bernoullis method. It is highly difficult. So that you can use CDF method. Okay, so for this, to calculate P of x greater than 1, I am going to use CDF, cumulative distribution function. So already we have P of x is greater than 1 can be written as P of 1 less than x less than infinity. It is the meaning of x greater than 1. So by using CDF, this can be written as f of infinity minus f of 1. Okay, so already we found f of x. What is capital F of x? This is capital F of x. So substitute infinity here. To find the capital F of infinity is 2 minus e power minus infinity 0 minus 2 e power minus infinity 0. So 2 minus 0 minus 0. So this is f of infinity. 2 minus 0 minus 0 minus f of 1. What is f of 1? Put x equal to 1 here. 2 minus e power minus 1 by 2 minus 2 e power 1 by 2. So substitute in the capital F of x equal to 1 is 2 minus e power minus 1 by 2 minus 2 e power minus 1 by 2. So this is the value. So now I am going to simplify. 2 minus 2 plus e power minus 1 by 2 plus 2 into e power minus 1 by 2. 2 cancel. So P of x greater than 1 is, adding these two, 3 into e power minus 1 by 2. So this is the answer. So next I am going to find out P of 1 less than x less than 2. So same, I am going to use CDF method. So what is the formula? P of A less than x less than b using CDF, f of b minus f of a. So that here f of b, f of 2 minus f of 1. Okay, so what is f of x? So this is f of x. Here I am going to put x equal to 2. That is f of x. So 2 minus 2 into e power minus 1, because 2 by 2 1 minus 2 into e power minus 1. So by putting x equal to 2 minus f of 1, put x equal to 1 here. Put x equal to 1 here. So 2 minus e power minus 1 by 2 minus 2 e power minus 1 by 2. So this is f of 1. So next I am going to simplify. So 2 minus 4 e power minus 1 minus 2. This is minus 3 e power minus 1 by 2. So minus of minus plus 3 e power minus 1 by 2. Cancel minus 2 and plus 2. So finally the answer is 3 e power minus 1 by 2 minus 4 e power minus 1. So this is the value of the function p of 1 less than x less than 2. Okay, so next I am going to find out e of x square. So the formula for e of x square is integral minus infinity to plus infinity x square f of x dx. Okay, so now the range of f of x is greater than 0, that means 0 to infinity x square into f of x. F of x is given by from the given problem, f of x is x by 2 into e power minus x by 2 into dx. Okay, now I want to integrate this. So take 1 by 2 outside. Integral 0 to infinity x square into x cube into e power minus x by 2. Again I am going to use Bernoullis method. Already we discussed the Bernoullis method, so I am going to apply the Bernoullis method. So algebraic term, this is exponential term. Take algebraic term first. Integrate the remaining term e power minus x by 2 by coefficient of x minus 1 by 2 minus differential of x cube is 3x square and integral of this is e power minus x by 2 by again minus 1 by 2. So minus 1 by 2 into minus 1 by 2, 1 by 4. Next positive. Differential of this is 6x. Integration of this is e power minus x by 2 by minus 1 by 2 here minus 1 by 8. So next minus differential of 6x is 6. Integration of this is e power minus x by 2 by coefficient of minus 2 minus minus plus 1 by 16. And the next differential is 0, so we can stop. This is Bernoullis method. The limit is 0 to infinity. Okay, so next I am going to simplify. The simplification is 1 by 2 into this 2 can take here, so minus 2x cube into e power minus x by 2. This is minus 12x square because denominator numerator into e power minus x by 2. Here minus, take this 48x into e power minus x by 2. So this is minus 16 into 6. 16 into 6. So what is 16 into 6? 96. So 96 into e power minus x by 2 with the limit 0 to infinity. Okay, now I am going to substitute the upper limit first. But you see the upper limit infinity, when you put infinity here, e power minus infinity is 0, e power minus infinity is 0, e power minus infinity is 0, e power minus infinity is 0. So entire upper limit is 0. Only in the lower limit. Substitute 0 here. 0 into anything 0, 0 into anything 0, 0 into anything 0. Here only the non-zero value. So all the terms are 0 except the last one. So last one minus 96 into e power 0. But e power 0 is 1. So this is 1 by 2 into 96. So cancel this 48. So e of x square is 48. So is the answer.